neutral cross-section for us today. And there is questions on homework 17 that have to do with alpha particle scattering. They are very similar to this. Please look at the book. Okay, so let's talk about one, which is the neutral cross-section. Let me define neutral cross-sections. Number one, both incident and target are neutral. That's number one. Number two, what kind of a collision do you need in order for this scattering to happen? A head-on collision. What's a head-on collision, guys? We talked about it in chapter 16. A head-on collision is a direct impact, right? I mean, they could be glancing, but they're like, they could come and hit, but you couldn't have it so where one particle is here, the other particle is there. It'll just pass by. It won't even see it, right? It has to be a head-on collision. Number three. Oh, I should have planned better. Number three. We now have to define what is called a scattering angle. What is a scattering angle? That one. Right? Absolutely. The angle at which the incident particle will scatter. Woohoo! And number four, scattering angle depends on B, where B was defined as the impact parameter. And what was impact parameter? B is defined as the perpendicular distance from the initial trajectory to a parallel line through the center of the target. I know you wanted the fancy definition, Sylvan, and there's what it is. But what do you think of when you think of impact parameter? A tunnel. Think of the bullseye. So good? What's the next thing? What's the relationship? So I just said theta S depends on B, yes? But what is the actual relationship between them? Here's theta S and here is B. Can they actually have a relationship? So we have to do a little bit of geometry. Okay, is this side B? Yes? Yes. This is incident angle. This is incident particle direction. This is scattered particle direction. What is the law of reflection? Incident angle equals the reflection. Good. Is this my Is this my incident angle? Is this my reflected angle? May I call both of them alphas? Is that allowed? Is the red line I've just drawn normal to the surface? So, do I know that alpha plus theta s equals 180 degrees? It's a straight line, correct? Angles on a straight line are? Can I replace 180 degrees with pi? Okay, so may I write this as 2 alpha plus theta s equals pi? Is this angle also alpha? Okay.
Can you zoom in a little bit, please?
Can I zoom in? Yes, I can. Okay, look at this angle. The one I'm drawing now. Look at that angle. Is this angle alpha?
Yes.
They're alternating
Angles. Yeah.
Alternating angles, right? Two angles, if they cross parallel lines, is this angle equals that angle?
Yes.
Okay. So that angle is alpha. I'm going to ignore this for now. May I call this angle beta? So then this angle is alpha. So far, so good. Is alpha plus beta plus 90 equals pi in a triangle? Is that going to be true? So may I rewrite this as alpha plus beta plus 90 degrees equals 180? Is that the sum of the triangles on the sum of the angles inside the triangle? Is that how we define them? So then may I write alpha plus beta equals pi by 2? Or may I write 2 alpha plus 2 beta equals pi? Yes? May I plug this value of pi in here? Not doing anything fancy yet. Oh, I never do anything fancy. Story of my life. 2 alpha plus 2 beta. Agreed? This goes away. What am I left with? Or beta equals theta s over 2. So that means this angle, beta, guys watch, is actually theta s over 2. Woohoo. So then may I write from here cosine of theta s over 2 equals b over r plus rh from this triangle in here. Okay, so if I take this purple writing, may I rewrite this as r plus rh cosine of theta s over 2 equals b? I have just redefined the impact parameters in terms of the scattering angle. Woohoo! And done nothing fancy at all. Do you want to do something less fancy? Differentiate this equation with respect to theta. What will you get? So if I call this 1, can I differentiate with respect to theta? What will it be? I should do differentiate with respect to theta. What is cosine? Differential of cosine? So this will just be r plus rh, negative sine of theta s over 2, then a half, right? equals dB over d theta. And what you will see in a lot of textbooks is this equation written like this. Oh, and then d theta, I forgot. That looks very scary. If you ignore what all the simple things we did before this. Like, if this is the only equation you see, you're like, oh, where did this come from? It's actually quite simple.